Hello friends, welcome to Susan and John Matthew. In this video, we're going to start a new topic, that is the C transform or the Z transform. Mathematically, the C transform will convert sequence into a function in the Z domain. So it looks like we start with a sequence, something like 2, 4, 6, or maybe something which looks like 1 minus 1, 1 minus 1, etc. into a function in the Z domain. So that exactly is the mathematical definition. But before we start, let's try to understand why some engineers can never ever avoid C transforms. Let's think from the perspective of an audio DSP engineer who is trying to create a new type of noise filter. Come on. When I am recording this video or when I say hello friends, welcome to Susan and John Matthew, there's a lot of background noise. But if I use a very good noise filter, you will be able to hear me, but you won't hear the background noise. So let's try to understand how it works. Let's start from the very basic stuff. When I speak or when we speak, we are pushing the air in front of us, and that helps the diaphragm in the microphone vibrate. And you know, in physics, if a coil moves around a magnet, it will produce electricity. So voice creates air vibration, and these vibration have pitch. That means loud and soft. So the sound is continuous, and my microphone picks up these sounds, converts it into electrical signal. Now the problem is these signals are continuous and it is like very smooth, and we can never ever, according to the current technology, store this into a computer or process or manipulate this. So there is a hero in the story, that is the ADC chip, analog to digital converter chip. So it will take any sound or it will cut any sound into 48,000 pieces every single second. That means when I speak for 5 seconds, the chip will convert it into 48,000 multiplied by 5 pieces. Okay, and the reason for 48,000, if you are interested, you can search about it. It is like the humans can hear from 20 hertz to 20,000 hertz, and there's a equation, there's a theorem which tells us why we keep it in 44.1 kilohertz to 48,000. Anyway, my point is different. So look at this. Every single second, the ADC chip will create a sequence with 48,000 terms. Can you see? The sequence has 48,000 terms. And I hope you still remember, Z transform will convert sequence into a function in the Z domain. And the formula for Z transform is, you can note it down. It is a summation k equal to 0 to infinity. You multiply the sequence with Z power minus k. Once you apply the formula, you will get a function in Z. Okay, so if I am not using any filter, then we don't need Z transform. The sound will just pass through, but you will hear all the background noise and the quality will not be good. Now, if you are designing a noise filter, the audio engineers will learn what all factors are giving us the disturbance. So, like what you call the Z transform is very useful in designing the filter equation. Anyway, now let's go for the math. So, look at this. This is the original sound, the sound that I am trying to push the air with, and the microphone captures this because the diaphragm is vibrating, and this is exactly what the microphone does. But this cannot be stored in a computer. So comes the hero, the ADC chip. And can you see? It is cutting everything into 48,000 pieces per second. And this is not even 1 second. Now, don't forget, this is the formula for set transform. And can you see? I'm applying a noise filter which is designed with the help of set transform, not directly, but it is designed with the help of set transform. And can you see, this looks almost like the original sound. And many noise which appeared in this will disappear and it will come like a super smooth sound. So once more, let's focus on the math part. Those who are learning digital signal processing, maybe in your third year, fourth year, will learn more about this. Okay, so the input is a sequence and the output is a function in the set domain, and the formula is given by sigma k equal to 0 to infinity, the sequence multiplied by set power minus k. So once more, people who cannot avoid set transform, audio engineers, control systems, robotic engineers, and etc. etc. And there are some people who need to know a little bit about set transform, but they are not going to use it because the software engineers will do their job. So they are the civil engineers, mechanical engineers, etc. etc. They just use the application. And now the funniest part is there are a lot of people who use set transform, but they don't even know they are using it. For examples, those who use mic, vloggers, musicians, whenever you talk on the phone, everywhere, gamers, everyone use it, but they never ever realize the noise filters are using set transform. Now let's work out a few problems. So please write the first question. Find the set transform of the sequence. I'm going to call the sequence u of k for a particular reason. 1, k greater than or equal to 0, 0 otherwise. So the question goes like this. Find the set transform of. So can you see the sequence goes like 1, 1, 1, 1. If you choose first term, second term, third term, fourth term, can you see the k value? And other side is 0, 0, 0, 0, 0. Anyway, it's so easy to work out. I want the set transform of u of k. That's the name of the sequence. And it is given by a summation k equal to 0 to infinity. You place the function. Multiply by set power minus k. Those who remember Laplace might remember something like this. In Laplace, we had integration and we used to write the function and multiply by the vanishing function e power minus st. So it's something similar. Okay, so this goes like u of 0 multiplied by set to the power minus 0 plus, because sigma means plus plus plus, and this is the counter, and u of 1 set to the power minus 1 plus u of 2 set to the power minus 2 plus etc. Now, according to the question, k greater than or equal to 0. So u0 is also given 1. So can you say 1 multiplied by 1 plus 1 multiplied by 1 by z plus 1 multiplied by 1 by z square. Now let me see how many of you learned Lorentz series properly. When we learned Lorentz series, we learned something called 1 minus x the whole power minus 1. It is given by 1 plus x square plus x cube plus etc. Provided mod x is less than 1. But now I want the reverse version. When you see this, I want you to recognize 1 minus x the whole power minus 1. So can you see I have 1 plus 1 by z plus 1 by z the whole square plus etc. which will be 1 minus 1 by z the whole power minus 1, which simplifies to You can take LCM, you'll get z minus 1 by z the whole power minus 1, which is z divided by z minus 1. By the way, this formula will work only if 1 by z under modulus is less than 1. So you can put the condition over here. That's it. So can you see we started with a sequence 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, and this is the transform. Okay, now let's go for one more question. So please note it down. Please write like this. Consider delta k. You will need this function later. Delta k equal to 1, k is equal to 0, and 0 otherwise. It's a very important sequence. We will talk about it later when we go deep into the subject. And the question is find the Z transform of delta k. Okay, very simple. How do you find the Z transform? Put sigma, write k equal to 0 to infinity. By the way, there is something called two-sided Z transform. Um, but for your syllabus purpose, this is enough. So you take this sequence multiply by z power minus k. So that will be delta 0 multiplied by z power minus 0 plus delta 1 z power minus 1 plus delta 2 z power minus 2 plus etc etc. What is delta 0 according to the question? It is 1 multiplied by 1 plus 0 multiplied by 1 by z plus 0 multiplied by 1 by z square plus etc. And that gives me 1. So remember, the Z transform of delta k is equal to 1. So I'll be back with more videos like this. So till then, my friends, bye.